Thank you very much, everyone, for those kind words. All back to you. Really being proud that I'm part of this movement, part of this great group of people, and have been for the last decade or more now. How time flies. Only having fun with PH, of course. And it's not going to be funky tonight. I'm going to put a different spin on it and try to keep all the technical stuff a little bit light. I know it's a little bit later for some of you in the Eastern time zones, so I don't want to bore you too much with technical details. But as you know me, the ones you know me, I could talk forever and get into the depths of those. So I'm definitely open to take it further if you have some more questions. I'll start my slides here now. Hope you can all see that.
Looks great.
So today, yeah, good. Today I'm going to tell you a fairy tale of the perfectly insulated building. And it starts once upon a time in the great white north, where most of us live. And there lived a princess called Gaia as well. Princess Gaia was always cold because her castle had no insulation, a terrible form factor, lots of thermal bridges, and an ACH of 50, only single pane windows, and no HRV. Her father, old King Cole, was at the end of his resources. And after a lot of thinking and consulting with his court, he made the announcement. Whoever could form a plan to provide thermal comfort for his Princess Gaia would have her hand in marriage. Suitors came from far and wide, among them Sir Heat-a-Lot from the country of unlimited resources, Herzog von Greenwash from the country of hypocrisy. But none of them were good enough for our Princess Gaia. She had almost given up hope when along came a young squire from the house of Passif, only armed with his wits and good intentions. And he presented her with his plan. 5 basic principles will guarantee thermal comfort as well as high level of energy efficiency. And as most of us know, there's thermal insulation at high levels, passive house windows that are high performance, orientated properly, using ventilation with heat recovery, getting high level of air tightness, and also try to avoid thermal bridging in design and construction. There could be a 6th that we could add, and that has to do with the form, the design of our buildings, how compact they are. But typically we talk about the 5. And today's focus is on the first principle, the super insulation. Very important for those who are new to the standard to realize the key element that it is a performance-based standard. So that means there is no prescriptive path, really. There is no rule of how much insulation do we need to put in our assemblies. A passive house in Vancouver looks different than a passive house in New York. And Princess Gaia asked, but where do we start and how do we figure out how much insulation we need for our projects? Well, you can start with a model, and that just goes hand in hand with our design. Definitely at a stage where we have schematic design ideas, volumetric ideas of our buildings. I highly recommend using Design PH. It's a very easy to learn tool. It's a plugin to SketchUp. Anyone can learn SketchUp in a few hours to draw enough that you can use it to start modeling your design project at an early stage. But it goes further. You can run different scenarios. So you see a little bit in the background here. A lot of this is from a project I've worked on. I started out with the baseline. So this particular project, they came to me and they already was designed, not as a passive house, but they asked me, can we make this a passive house? And I said, yeah, I'll try and I'll model it and see what we can do. So started out with a baseline, and it was around 70 kilowatt hours of heating demand. And just by changing the quality of the windows, that already dropped down to around 30. And then start looking at the assemblies and the U values of those. So definitely one of the first kick at the can when you're looking at a passive house building and figuring out how much do we need, how much insulation do we need, what do we need to look at in terms of U values. Another approach would be to look for projects in your climatic region and get a basic idea of the adequate U values. There is an international passive house database, I'm sure you're familiar with, passivehouse.com will lead you there. Look for your region, look what has been done. I know Passive House Canada has their own one. I'm not sure what's happening in the US in that regards, but take advantage of your colleagues in your areas, even if you walk around and see someone is building a passive house. Ask them what they're doing, and we're all sharing our lessons learned, and the Passive House Accelerator is the perfect example for that, where we can learn from each other the most. And remember that size and form do matter, and especially for smaller buildings, I would say they don't even have to have a very intricate envelope that has a lot of chalks and makes it bigger. It really depends also just on how many stories you have. I was looking at a passive house in Ottawa. That was a one-story rancher with a courtyard in it. And I had to tell the client, unless you're adding another floor or a basement, it's not very feasible to get to the certification. So for us who are in the single family world, in the laneway infill house world, it's very tough sometimes to get to the full certification. Much easier to have multi-story unit residential projects or towers, etc. Definitely gets easier in terms of what we have to do in terms of insulation values for our wall assembly in particular. And for example, a single family home in Vancouver could use 6 to 8 inches of exterior insulation. A 4 or 5 story building that's a multi-unit residential could use 3 or 4. So it could be that drastic. So keep that in mind. You just got to know that and know that you have to work extra hard if you're working with smaller buildings. And then don't forget about your site restrictions. A lot of us are designing and working in city environments. There is setbacks, there's fire regulations, and then also what's around your site. Are there any tall buildings, or is there any tall buildings planned maybe across the street on the south side? Vancouver has a lot of trees. It's always, that's a lot of the time, the main thing we factor in is the trees that are lining the street. And then some of us are in mountainous regions where we have a mountain range that's quite far away, and it can actually impact our solar gains quite a bit as well. So again, promoting design pH, particularly for this stage of your design, where you can add those in. You don't have to get fancy and draw a whole mountain range. What I did recently for a project in Pemberton is figured out how far are the tallest mountains away, and all I did was draw a plane in that direction, and that already kind of acts as, the program reads it and realizes, oh, hold on, we don't get any solar gains after a certain time anymore because the sun is behind the mountains. Princess Gaia is asking again, now that we have figured out what range of insulation values we require, how do we choose the right assembly and the right details? I really enjoy or like this. I used some of these slides, probably some of you have taken classes with me, recognize them, and they don't necessarily come from me, they come from my colleagues as well. And I always try to kind of, find an easier way to explain things. And this is one of the slides I really like, especially when we're talking about light timber frame, with non-combustible commercial assemblies. But there's a lot of options always. And again, the advantage of having a performance-based standard is that there is no rules of how we're building our walls, really. As long as we get the U value that we're modeling out of it and put the right values in there, anything really works. So this slide really talks about like wood frame and how can we add more insulation into our assemblies. So there's two major ideas. We either stuff more insulation into our walls, and at some point, we're increasing the depth of those walls. And we'll get more into the details of what that could look like. And the other idea is to start wrapping our existing structure with more insulation with insulation panels. So I picked a few here. There's a lot of variations to this, and don't think, again, this is kind of a rule book or what you have to do. It's just showing some of the commonly used assemblies that most of them we have worked with personally, and I can, tell you some of the advantages and disadvantages of these. So in our cool temperate climates, it's very important that we differentiate this. Where do we build this passive house building? Because how much insulation, is kind of the average, will differ if it's a cold climate or a cool temperate climate or a warm climate. So for us, we are in the cool temperate climate, and Vancouver happens to be the same climate as in Central Europe, same as, where Darmstadt, where the Passive House Institute is. So a lot of literature is based on that climate zone. If we're looking at the stuff it category, the easiest one we see in that is a 2x8 or a 2x10 wall that's insulated. And we're getting I got it both here, a metric U value of around 0.1 to 0.16 out of that, or a imperial R value of around 36 to 53. So that would be enough here, say, for a single family home. Medium size. One thing you notice here in that little isometric is that something has changed from kind of what we are used to in our buildup of our stud frame wall. We see the plywood or OSB sitting on the inside. And there's a few reasons why you can do that. The main one is really if we're putting it into that position where it's on the warm side of our insulation, it can actually act as our vapor retarder layer. And the structural engineers, they not really care about where you get that strength, that shear strength from, if it's on the outside or the inside. So that means you can get away without using a vapor retarder membrane. So you don't need a, poly, what we used to do, but no Proclima, Intello, or Siga Myrex. You can just use the plywood. And then if you want, you can also make that your primary airtight layer. So now you're adding another function to this material you're already having in your assembly that your structural engineer is asking you to use, because the building would fall down like a house of cards if you wouldn't have it. So we making it the vapor control layer, and we can tape it airtight. So now we got everything in one plane. So it happens quite often. So because really it's an economic kind of question of spending more money on material and labor. And now, of course, we not talk too much about airtightness, but you always want to protect our airtight layers. So we would add in a service cavity to the inside. That's that 2x4 framing you see indicated on this drawing, where we can run our electrical, even plumbing now on exterior walls, because it's way on the warm side. So calling this the deep stall wall, sometimes called the fat wall as well. It's one of the most preferred prefabricated panel systems as well. And I saw Jan in the audience there. Hey, Jan, this is, you guys put those panels together for us from Collective Carpentry. And this was actually, quite a large passive house we built in outside of Vancouver, 7,000 square feet. Completely panelized offsite, walls, roof, even intermediate floors. So we used exactly that build-up. We can see the OSB already taped from the factory, and then the panels getting installed on site. The one on the right, a little infill house in Vancouver we worked on, that we didn't have set up a crane, not putting any or staging any panels either. So we decided in the end to hand frame it, but still went with that same assembly. One thing to note about this assembly, a lot of time the floors are latchered in, so it's more like a balloon frame than a platform frame, just to kind of make that transition between floors easier in terms of carrying the air tightness through. Now, if we're looking at a cold climate, then we're still in the stuff it category. We need more space than a 2x10. Once you get to 2x12, I think these panels will get way too heavy. So I'll call this the original Canadian high performance wall. And literally, you know, some of you may have heard of Harold Orr and the Saskatchewan Conservation House, which was built in 1970s. And was the first, high efficient house in, I think, maybe North America, which was influential also for Wolfgang and Bo Adamson, who founded the standard. Anyway, they used this assembly there. So I'm pretty sure that this Harold Orr kind of figured this out. He's very humble about, you know, his multiple skills, but the double stop wall. So the idea is that you have one structural 2x4 and then one that's non-structural, and you move them apart as much as you want to get the right amount of insulation you require. So definitely something that's more suitable for a cold climate. Typically the cavity gets filled with dense packed insulation. A little bit trickier to detail all the vapor and airtight layers. I won't get into that too much. Now, rapid is pretty self-explanatory. You're using some form of exterior insulation panels and you wrap them to the outside, or you put them to the outside of your structure. It's like putting on a wool sweater over top of your building. Obviously with that, there's less thermal bridging. We don't have any studs anymore that are thermal bridging every 16 inches. We could do this on top of a regular 2x4 or 2x6 frame. What I'm showing here in the illustration is a CLT panel, mass timber. Could be mass anything. It could be mass concrete, mass block. Definitely one of the most used assemblies for any building that has a bit of insulation, really. And in our experience, this is kind of what we use as our go-to assembly that we do for new construction. And we're using between 6 and 8 inches to the outside. So typically 2 layers of panels that are either 3 or 4 inches. And most of the time we're using mineral wool for this, but you could use wood fiber as well. We'll talk a little bit more about, you know, why would you choose one material over the other. The trick is really to attach the cladding through it. So that's where it gets a little bit difficult. Very easy to do on a CLT. You just, you know, hit the screws wherever. It's mass timber, right? Even the highest density mineral wool or wood fiber will have a bit of flexibility once you tighten those screws in. Those battens will get sucked in. You're gonna get off plane a bit. So it becomes critical that you have some kind of a system in place to straighten out those walls. What we do is just, you know, string line it, plumb the corners, and then work our way up just before we put the cladding on, and just either suck the screw in a bit more or back it off just to straighten it out. If you're going on top of a wood frame, you may have to hit the studs, or you may upgrade your sheeting to 3/4, where it's easier to support some lightweight cladding. If we're looking now at the rapid for a colder climate, I think 2 panels is, in my experience, kind of the most 2 layers it can do. I've seen people, you know, illustrations of 3 or 4. I think you'll get really cumbersome. You need really long screws, and will get not very practical on site. So we have this exterior box that gets added on to a framing. So that could be either made out of a Larsen truss, which is in the top right. It's kind of a cheap handmade truss. A TGI, which is a wood I-joist. That's just off the shelf. They're really designed for floor or roof structures, but you can use them as a thermally broken wood element to build this non-structural box to the outside of our structure. And then it gives you the chance to fill that with insulation again. Bottom right is UMBC, that's a university in Prince George, cold climate, wood innovation campus, a timber frame structure behind this, and they actually used a full truss to build the walls and then insulate in between them. Now, we talked about how a few different methods to get that insulation in. There's a few things we always have to consider, and one of them is our building science. So anything to do with moisture management. So having moisture inside the building, vapor drive, can that dry out to the outside? Very important to not trap any moisture between two vapor type materials. Also, obviously looking at exterior moisture, ambient humidity, rain, snow, wind-driven rain, anything like that. That's what our cladding is for. So we're always talking about the 5 critical layers that we need to have in our assembly. So they will look different depending on how you're building up your wall. And here's just an example. And again, for some of them, there is different approaches. Even in this one, there's a few different ways to get your air tightness on that picture on the right. But always consider that. And if you're having some materials you're not quite sure of, maybe do a hygrothermal model where you figure out, am I gonna have some issues with trapping moisture in this assembly? We just talked about walls for now, but really this all ties into a bigger picture. You need to have a grand plan for your assemblies. It doesn't make sense to, switch from exterior insulated to interior insulated between foundation and walls above grade and then to the roof. So really look at the building more as a whole. And with passive house, we typically put a uniform amount of insulation around a building. We don't just favor the attic versus the, a little under the slab and more on the walls. So it's a bit more uniform. And this is a nice example of where the architect really lined things up. If you're lining things up, it's easier to build and it's going to be cheaper. So it is definitely doable. It doesn't have to be rocket science. Don't forget about the windows. The windows are the most critical piece in your assembly in terms of everything coming together there, your airtight layer, your insulation layer. And just a couple of examples from our job sites. One where we had that exterior TGI, where we had to build a buck to put the window in. And then we're over-insulating the frames a little bit. The one on the right is an exterior insulated one where we actually push the windows out into the insulation cavity. So we're using fiberglass angles to support it. And then we're gonna build the insulation around this once it's all waterproof. Don't forget about thermal bridging. So first of all, thermal bridging can occur at any change of direction, at any change of material assemblies. So going through our section and figure out how we're doing in terms of thermal bridging. And if you're using exterior insulation, we really got to pay attention to what is the cladding system. How do we tie that facade back to our wall without creating a thermal bridge? So the old metal set gird that was really like highly conductive, really kind of avoided the insulation value of that exterior insulation. So we have now nice clips made out of fiberglass or stainless steel, some really broken, or we can use screws and minimize those thermal bridges. Now, Gaia, obviously named after, Mother Earth goddess, is really concerned about Mother Earth as well. And she asks, how do I minimize the impact on the environment with all these extra materials? First of all, if you have an existing building, consider renovating it, doing a deep energy retrofit. Use the Passive House tool, EnerFit, to certify it. Got some excellent examples out of Brooklyn, all those brownstone buildings. We have a few in Canada, not enough in my opinion yet. One that comes to mind is the Ken Sobel Tower, which is a multi-story concrete building that got exterior insulated. Really, we have to start thinking about our resources. And I was talking to a Swedish, actually a cycling friend of mine, but he was saying, Well, Sweden is already looking at that they're running out of cement. They don't have concrete forever. They're already starting to look at alternatives to cement. So I never thought of that cement is a resource that actually is going to run out, but we'll face this in our lifetime. So we got to think differently about, what we do with our existing building stock and how can we reuse what we have, keeping the structure, if possible, reusing some materials. So I think that would be the first step really to get into before we even look what the embodied carbon is of materials, which definitely is something I would do looking at new builds, and something that actually is getting implemented already into the Passive House standard. pH ribbon is something that some of you may have heard of. It's a tool to look at what is the embodied carbon. And for some of you who are not familiar with the term, this illustration really shows it. It's looking at the entire kind of life cycle of a material. It looks at the extraction of the raw material into the processing, manufacturing, transportation, and the use, and then also the recycling stage or the end use of the material. So obviously there's some materials that are just very high intense in energy. When I went to school a long time ago, we just talked about embodied energy and how we basically just spinning that with carbon, because energy is, carbon emissions if you use fossil fuels. So the ones who are really bad are the ones who use a lot of energy. And there's spray foam, all the plastics are there, there's made from oil, etc. And then as we're getting into the more natural materials, especially the ones that are grown, they actually sequester carbon. That means a plant absorbs CO2 during its growth. And if we don't burn it and releasing that carbon again, we're locking that carbon into that material. So using wood, the most typical naturally grown material we work with, actually is a really good thing to use that for construction in terms of low embodied carbon, using mass timber and using light wood frame, using wood insulation, wood fiber insulation, and obviously cellulose, a byproduct of that too, or cork, wool, hempcrete, all these different things we see. So definitely something I would consider. It's always a question of can you get the material and how expensive it is as well. And talking about expense, Gaia says, that sounds all good, but my father has a budget. How much will this all cost? I always like to explain it this way. It's an economic model really to explain why high performance buildings make sense in a very easy way. And the model is called the cost of monthly ownership. So basically, you're figuring out what is your premium to go to high performance, to Passive House. And then you figure out the additional mortgage payments you're going to have to pay per month. So you let the bank carry that additional. And then you subtract the savings you're having from your energy bill. And then if you're basically even negative under the bottom line, it's a no-brainer. You're saving money every month, right? So who wouldn't want to save $135 each month? Let the bank carry that extra premium to go high performance, and you're having the savings. Now, this is a project of ours where we incorporated photovoltaic. So they're even generating, and you see there's energy production. So there's even a bit more, but obviously that costs quite a bit of money too. So even with that kind of scenario, it starts making sense for these clients, homeowners, building owners to use the high performance standard and saving for the lifespan of the building. The next thing I like this Pempina Institute list here. They figured out how much does it cost to save a kilowatt hour or to produce a kilowatt hour. And you buy it from BC Hydro or whatever, from your utility. That's one cost. Or you can buy all this equipment and put it on your building, and you figure out how much did that cost and how much is the yield, and then you get a kilowatt hour cost as well. The cheapest way to buy energy is actually to conserve it. So to buy insulation, to buy good windows, to buy an HRV, to buy membranes for air tightness. You start with that, and you're much cheaper than anything else that you can buy, any kilowatt hour you can buy on the market. So this is another good way I find to really make an economic point for high performance building standards like Passive House. I did a presentation a few years ago, and we looked at a few different buildings. This was with a colleague of mine, Lucio Picciano, and we were in Munich at the International Passive House Conference, and we looked at a few of our buildings, and we looked at the spread kind of between where we're spending money on Passive House features like windows, insulation tapes, and the HRV, and we compared it to a regular building. This is just a little snippet out of it. I really want to just draw your attention to how big that pie is, the pale blue, which is interior and exterior finishes. We have a lot of control over that part of the pie, right? We don't have as much when we're doing a Passive House over, you know, the structure, the insulation, the windows, the HRV. But we can save a lot using more maybe off-the-shelf, not too super expensive interior and exterior finishes. So this is a concept we do in our residential, you know, single-family building a lot. And you know, the owners get it and go, okay, I don't need this expensive tile from Italy. I can do something else, or it's just being smart about their choices. So both Princess Gaia and King Cole were convinced. They hired the squire by the way, his name was Wolfgang, of course, to conduct an interfit on the castle. And after the completion, there was a big party to celebrate the Passive House certification and the royal wedding. And Gaia and Wolfgang lived happily ever after in their energy efficient castle, full of summer comforts to the end of their life. And that's it with the official presentation. I hope you enjoyed it.
What a lovely fairy tale. Thank you, Marcel. Great way to tell a story and bringing us along the way and sharing your work. So we really appreciate it.
Thanks, Dan.
Any other? Sean, who are your friends?
Well, you might know of our good friends Peter Moonen and Jerry McConney. We're live from Portland. You never know who's going to get brought into the presentation. So it's, again, we're actually seeing these real life people. They actually exist. They're not just, you know, virtual friends. So great stuff, Marcel. Again, we expected a good performance, but you outdid yourself with the storytelling. I think we're all going to try to figure out how to copyright and publish it so we can say it to all the kids. So fantastic presentation, Marcel.
Thanks, Sean, and hi to everyone in Portland. Hey, Peter.
Send me a copy, that's so I can read it to my kids at night when I get home.
Yeah.
It'll be on YouTube. Sean, Shannon, Mark, Shannon.
I want to add there's one small portion, Jerry, that wasn't in here, and that's my favorite quote of yours, and that's precision equals performance, my friend.
Yes, sir. Marcel.
Hey, Marcel. Peter wanted to say something.
Oh, I don't see any wood fiber insulation in there, Marcel. You're gonna be updating that chart?
As soon as we get some made here in BC, yes. I tried to get some from Europe, but it was crazy.
Did Wolfgang have any supply issues getting things to the castle?
Yeah, definitely in the last couple of years, I would say. And now again, because of a crazy guy in the East, the evil wizard of the East.
King Cole does not like shipping air.
Exactly.
No, and that wood fiber can get a little bit heavy, right?
Yeah.
Well, thank you, Marcel. What a fantastic presentation. You've taken us on quite the fairy tale trip. And I wish I could have only pulled in more children to watch along with me, because it was perfect. Storybook ending. We have a few questions we can take right now while we finish out our first hour. And the first one is from Enrique. Enrique, would you like to unmute and ask one of your two questions?
Yes, thank you, Sharon. The question I had in one of your slides, the stuff cold temperature climate, the deep stud wall, the 2x8 or 2x10, doesn't seem to have any exterior insulation continuous. So how do you manage there the thermal bridging then of the studs?
It's calculated in the U value. The good thing about wood is that, you know, we can get away with those wood studs. It's not a really bad transmitter of heat. It does have a pretty good thermal, you know, a little thermal conductivity. So we've factored that in the U value. Basically gets right built into the U value calculation. If we would use steel studs, so that's a completely different story, you know, because much higher conductivity than wood. So we can get away with that, yeah.
Maybe because it's cool temperature climates there.
Yeah. I mean, it's always everything plays together, right? So that's just one little part, but you know, there's lots of examples of passive house that have been built like that. And I'm not sure in a cool temper you would have, or in a cold you would have some exterior insulation on top of it. And of course you could do that easily if you wanted to, right? So you start with a 2x8, 2x10, and then just add, you know, 2 or 3 inches of exterior insulation. I just kind of simplified them because there's a lot of combination and variations to these assemblies I showed.
Yeah. And if I may, I would like to ask a second question in your
Sure.
chart of embodied energy. You're showing the XPS equal as EPS. We're always told that EPS has a much lower embodied carbon than XPS. So why is it showing there the same in the chart?
I'm not quite sure. This the source is from architecture 2019. It could be that something in the, you know, in the makeup, the blowing agent has changed. I know there's a lot of more greener foam products now too. Yeah, I'm not quite sure why that would be different. In the end, when you're doing a embodied carbon calculation, you would need to get a specific, they're called tickets for your material that really shows you exactly what's in there. This is just a very general kind of, you know, abstract slide. So if you have a particular material in mind, you would look at that and then compare it.
Okay, thank you. Very good presentation. Excellent. Thanks.
Agreed. Thank you, Enrique. Next up, we have Richard Arnett.
Afternoon. Trying to go back here. You showed some pictures of the double ply slip panel, I think it is. And I think in the chat we were going through that, and I was reckoning that the extra layer of ply was between $6,000 to $10,000 extra dollars for a house. And then somebody else offered a comment to say, well, can we get rid of it? And I was saying, well, you could poly wrap the inside face and put some battens to protect it during transport, and then use that then as an electrical rough-in zone and fill the gap in with an EPS board to increase your value, and then close it up with gyprock. So yeah, we've just been chatting about that in the background while you've been talking.
Sure, yeah, I can get some more. Typically, we actually don't use 2 layers of plywood. We just use the one. We use it on the inside. And then on the outside, you either just stretch your WRB, so that's your building wrap, your Proclima, Mento, Siga, MyVest, whatever you're using. Or you could use an insulation panel. Particularly good is a vapor diffusion open insulation panel, like wood fiber insulation, cork insulation, something like that, because you don't want to trap any moisture. So I know, like, you know, plywood used to be one of the cheapest materials. Now we're paying over $100 for it.
Not any longer.
Yeah. So yeah, but I wouldn't actually recommend to use 2 layers just because of building science kind of issues of potentially trapping the moisture in there. So it is better to keep it vapor diffusion open to the outside. And if you can get away from the poly, you know, and using the structural sheeting on the inside, I think that's, you know, cost savings as well.
Okay. Thanks, Marcel. Great talk.
Welcome.
Fantastic. Thank you so much, Richard. And next we have Martin. Martin Volker, would you like to unmute and ask your question? Are you still with us, Martin? Looks like you're here. I will ask your question. Oh,
Okay.
there you go.
There I go. Actually, my first question was well answered in the chat. It was about whether a 2x10 isn't already sufficient. So I'd rather ask my second question, which is about wood fiber boards, which apparently in Europe have been used for 20 years, and they're being called a best-in-class insulation. So my question is whether Marcel has any experience with this kind of material. And I was also pointing out that there's new factories starting out in Maine making that kind of stuff.
Okay, yeah, so I grew up in the Alpine regions of Europe and Switzerland. So yeah, that's where wood fiber insulation comes from. It's made from, byproduct of sawmills. It's basically just sawdust. It doesn't even have any glues in it. It's really just relying on the natural resin of the wood fibers to pull them together. They heat it up and press it together. It's not as simple of a process as I'm explaining it now. There's been a lot of talk about, and actually the person Sean is with, Peter Moore, and he's involved in, in this has been for the last, 5-6 years or more to get the production started in North America of this. So it's the first time here that something is happening in Maine. I'm not always also up to date what's happening south of the border, but it makes sense. We got so much wood here, Canada, north parts of the US as well. So it's just a matter of time till we start manufacturing that here. It is a very good product in terms of being a recycled product, 100%. It's not very good with fire. No, okay. Kevin could comment on that because it's quite dense. So it's not just like a bunch of kindling that just catches fire, but it's not that great with moisture. So we typically will have to protect it with a membrane if we're using it on the wet West Coast here. I haven't personally used large amounts of it. We use it in a smaller amount of like, 3/4 inch panel on some of the assemblies. But I know people who have at the moment, or in the past, it still has been imported from Europe, and shipping, trapped air in wood fiber across a continent and an ocean doesn't make that much sense in my opinion, but it's definitely doable. Yeah.
Thank you, Marcel. Next question up is from John Pearl. John, would you like to come on and ask your question?
Yeah, sorry, I was had a different screen.
That's okay. You're across the pond in Australia, so it is a little delayed.
Yeah, slow internet here. I think I got my question answered in the chat, but I was looking at the wrap model, and I got quite a bit of thickness between the outside cladding and the frame, or the CLT wall, I think it was in that case. And I didn't see the screws going all the way through. And I'm wondering whether structurally how that layer in between the CLT and the cladding are secured. Do those screws go all the way through?
Yes.
Yeah, they do.
Yeah, they definitely go through, and they have to go, I think the rule of thumb is like at least 1.5 inches into the structure. Depends a bit on the weight of your cladding. The spacing of the screws depends on the weight. We also, when we do this, put a screw at a 45-degree angle upwards at every kind of floor level, but this will prevent long-term creep of the facade. Because if you think about a screw and it just goes straight in and it's made out of metal, over time that metal will kind of fatigue and bend, right? So you could get some shifting in your exterior cladding. So by having a perpendicular screw and then one at 45, you're creating this really strong triangle, static, shape that it's like a truss, right? So it actually helps to support that even more. Other methods would be clips. Definitely use that, right? So it doesn't have to be screws, but screws definitely in this kind of application, probably the most common one.
Was that, thank you. So that 45 was downwards, I assume, so that it
no, upwards, because steel is really good at pull force, right? Tensile strength. So going up at 45. Yeah. down you would load it with compression, right? So it's not that great if you have a 1/4 inch of a steel screw or something like that.
Yeah, I don't want to hog the question, but I've actually got an Inefit project, which is a brick or a cement block wall, which we're looking to wrap. It's up in the snow, and we were looking at securing these not low thermal point bridge screws into the cement block, and then coming out with the insulation and then battens and then securing it that way. So there's 2 steps to it, but what you're doing is one all the way through. Yeah.
Yeah, but that's because it's wood. I would do it different too if you're going into block. Probably you would end up using a clip. There's some pretty good clips out there. Obviously, fiberglass from Cascadia. You could order them, I guess, worldwide from Canada here. And then there's also some really good, suddenly broken stainless steel clips that you could use. What you're talking about is inserting like a threaded rod kind of into the block and then putting on the insulation panels and then screwing the battens on. That could work as well.
That's it. Yeah. Okay. Thank you. Great story.
Thanks.
It's not such a fairy tale, though. It's reality.
No.
Marcel, I changed my background to your fairy tale castle back here.
Oh, nice.
It's a
Very
thermal
nice.
image of a multifamily. And actually you can see Princess Gaia at the window.
Yes.
Calling for her, her rescue.
Yeah, I can see that. Yeah, she's pretty, giving off a lot of heat.
Your picture, she's very attractive.
Good.
And it's gone from a fairy tale to a true story and a love story. Sean, you want to let us in the window into the Mass Timber Conference?
Well, everybody, I mean, Marcel, that was a great presentation, great questions, and we're going to continue it again. These two are going to maybe dive off to the social area of the Mass Timber. I will catch up to them a bit, but it's time for the overtime. And I think I froze. Uh-oh.
No, you look good. Everything's clear as a bell on our end, but we are glad you're going to jump into a social hour over there because we're going to do the same over here. We've got a lot of questions in the chat. And thank you, gentlemen, for joining us with Sean. And have a good time tonight for me. I wish I was with you.
You're here in spirit, Shannon.
Hey, Shannon, before we go into after hours, since we had the best fairy tale of our lives, can we do the unmuting and clap and scream and shout and thank Marcel?
Bravo.
Thanks, everyone.
Marcel. Great job.
Thank you, Marcel.
Thank you.
Thanks. I had a lot of fun doing this. Don't get me wrong. It was not a chore. I laughed as hard as you probably did when I put some of these slides together. And yeah, it's good to have a bit of fun, right? Life is too serious sometimes.
You did a great job. One of the things I mentioned in the pre-show, and you mentioned it earlier, Marcel, was during COVID, shutting down and keeping this community open has really made us grow together. I mean, on this call tonight, we had over 170 people, and each week we come to learn and improve upon. And your message is great about keeping true to Passive House and stay the performance path, and not everything is fluid. But calling you a friend and somebody I can call when I have a question, I mentioned in the pre-show, is steel sharpening steel. We're all getting better. We're accelerating Passive House by pushing each other to the next level of getting better performance on our blower door numbers, better wall assemblies. Just the innovative questions in the chat tonight were phenomenal. People trying to figure out ways to do it better, faster, easier, cheaper. And I'm so proud to be a part of this community. And I thank you for being one of the members and everyone else for joining. So it's really great to be a part here. Thank you.
Kevin, I couldn't have said it better myself. And I'm so glad to share this space with you and Sean and Zach and Mark and everybody at the Accelerator, because there's no better place to point to when you want to help somebody find their way, whether they're experienced and they want to see a project similar to the one they're doing, or if they're new and they're just trying to figure it out. There's tons of tools on the site. There's a great Q&A where you can post questions and get answers from experts that are rating those questions up. And speaking of questions, we've got 3 more coming up. The first from Scott Kennedy.
So actually, my first one's actually for Peter, who's sitting beside Sean there at the Wood Conference. And the question for Peter is, when are we going to get a good wood insulation plant out here on the West Coast?
Yeah, I'm pointing at Marcel. So I agree, Scott. I think that it is just a matter of time. But certainly there's the demand. As Sean was just telling me about some of the difficulties about supply. So really it comes down to making a business case. And I am working with others on that. And I'll give you a call sometime over a glass of wine and some Cambozola.
Sounds good.
Okay.
Anyways, back to Marcel. My question for Marcel was, when you put dense pack cellulose in, are you injecting it from the inside through the plywood or from the outside through the moisture barrier? And which is better? And then how do you ensure you've got the density, particularly if you're going from the inside through the plywood?
So that would be for either the 2x10 or maybe the TGI wall, right? You're talking about. Yeah, we thought when we did a 9 1/4 TGI in Whistler, which is, you know, colder climate than Vancouver, and for passive house there, we thought that you know, the insulation contractor would do it from the outside, but they said, no, we're not going to climb a scaffolding with our hoses. We're going to do it from the inside. So that was kind of, you know, already the answer to that. So they did drill holes into the plywood. And well, the calculation of the density is basically a calculation, right? You figure out your cavity space and how much pounds of insulation material, raw material, and then they show up with the bags on site and they dense pack it in. It's a little bit easier when you have an open cavity. We actually moved away from using like an enforced vapor membrane like in Tello, or I guess with Siga Myrex you could do it too. First of all, because they're airtight, right? So when you're blowing in something with air, the air has to go somewhere too. So what they typically install is this netting, and that lets the air escape. And it's also much more translucent or transparent, so you can see the quality of the install. So we typically would just get, and it's cheap material they use, and it doesn't necessarily add too much to the cost, and they install it themselves. So they tack that on, do the dense pack. And then if we need a vapor control layer, we go over it later. A lot of the times you might even have to do a bit of a furring as well, because it is densely in there and it will bow out a bit. And so, yeah, that's kind of the answer to that part.
Marcel, I can jump in just to answer. Count the quantity, measure the density, and go from the outside where you can touch and feel it is a lot easier than going from the inside. Depending on the weather, honestly, but measure the density. You can take a core sample and measure it, and then as you increase from typical 2x4, 2x6 construction, going to 2x8, 2x10, you should increase your density. You should be up to closer to 3.84 pounds per cubic foot. Test but verify.
So I guess the question is, I've got a 24-inch cavity up north that we're, well, 16-inch cavity up north that we're going to blow. And it's 3-story building, so I'm not sure if they're blowing it from the inside or the outside. But if you blow it from the inside and you got the eye joists, and we've got Myrex on the outside, or no, we've got Siga's, or not, we've got 475's product on the outside, Mento, sorry, on the outside. So we're going to have that air issue. So I assume we're going to have to drill, maybe if we do it from the inside, you drill 2 holes. One, you drill a couple, one to let the air out and get the hose down, and
you go in lifts. You go in lifts of about, I don't know, Kevin knows better. He does it himself, so he's pretty expert. But I think it's like 8 feet max or something you can lift in one go.
So it depends on which nozzle they're using. There's a very innovative nozzle called the ventilated rotary nozzle that allows the air out. If they can get their hands on that, that's helpful. But you might need more holes. The 2-hole method of slitting holes in the membrane, kind of old school, not really that great. You're better off using like a dense pack tube. The greater, you know, that you're gonna have more efficiency blowing if you're above 2.5 inches. And then at the tip is where it's gonna dense pack and then come out, and that's normally around 6 or 8 feet. You know, and then checking your density, and then it's nozzle, whoever's running the nozzle, just have that integrity of being able to touch and feel to go up. So I would suggest doing it from the outside. This way you can touch and feel the membrane. If you look at a lot of the European examples of dense pack cellulose, the X-Flock videos and all that are out there, a lot of times they're doing it from the outside when they're doing that type of assembly. But trust but verify, and make sure that they're counting. They have a count, a good on what quantity they're bringing to the site, and always have a little extra, and make sure that they're testing their density. It should be like a firm mattress, but even though it's a firm mattress, you still have to test it. You should weigh it. It's not that. It's pretty simple.
So to weigh it, you cut through the membrane on the outside with and weigh a sample. Is that how you're doing it?
Yep, a very simple 4-inch dryer vent and a chart will tell you what it is in a simple scale, and then I put it in a brown paper bag and stuff it right back in, because the bag's vapor open, and then tape it.
Okay.
And you can see Kevin do that on that link I threw into the chat, where he talks all about dense pack, and he even shows you how to make a schedule for all of your bags before you start using them, so you can keep a count and know how many you've put in and how many are still hanging out.
My problem is I'm here and they're,
Oh yeah, Scott, I know that problem. I am with you. And as
I'm not going to be able,
usual,
I'm not going to be able to witness it, right? So I've got to have to come up with some way of making sure that it gets done. So that's the problem. Yeah.
Yeah.
Scott, you just require daily testing. So just to ask them to send you a picture daily of where they worked, and do at least one test per day.
Okay.
And then it's an instant feedback loop. So if something goes wrong, their hoses become leaky, their machine setting changes, you're going to instantly know that you have a thing. You're not going to be 4 or 5 days in the project and know that your density's off if you're testing every day, or 2 times a day.
All right. Great. Hey, thanks, guys. That's good.
No problem.
Great advice. And I love the paper bag trick, Kevin. Our next question up is from Perek.
Hi. Thanks, Marcel. Romance and Passive House. Hi, Shannon. It's awesome. Never thought I'd see that day. Anyway, my question is related to where you're talking about the very cold assemblies, and you're talking about exterior insulation, where you showed the truss, the I-joist on the outside, and the truss, which I think are both challenging to install. So my question was, particularly when you're talking about wood studs, can you not put 8 inches of insulation on the outside and fill up the studs, let's say 6 inch of insulation in the wood studs? Will that not do the trick?
So Bill, instead of using a TGI, using another
you
could potentially do that. But if you're lining that up with the main structure as well, now you got like a 14-inch piece of solid wood, right, going through your wall, and that thermal bridging effect is bigger. The reason why we would use a TGI is because it's a thermally broken assembly already, by having the OSB cord in the middle, and then the bottom and the webbing, sorry, not the cord, and the cords are made out of LVL or whatever. So the idea of using that TGI is, first of all, it's nice and straight and lighter, and also it's thermally broken. But if you find a way that you could stagger it, the exterior insulation frame, let's call it, right? Then, you're not facing that problem as much, and you could definitely do something like that.
Yeah. Well, and the reason I say 8 inches is because that's sort of the outer limit of where you would put clips or direct fastening, which are maybe simpler solutions. But
yeah, with 8 inches, I would do 2 layers of 4-inch wood panels or wood fiber panels. Yeah. Anything beyond that, the 8 inches gets more difficult.
Yeah, no, I completely get that. That's what I was thinking. Pushing some onto the inside relieves the need for putting more on the outside, and those more challenging solutions. Okay. No, thanks. The other thing was just a question, a comment. I mean, you had the picture up there on the impacts of the various forms of insulation, but and I think it was in the chat, but I think as of like a year ago in Canada anyway, spray foam insulations as an example, and I think rigids as well, all have to use HFOs in there as blowing agents. And that, while it's not going to be anywhere close to what wood fiber is going to be, it's still a hell of a lot better than what it was.
Mhm.
Yeah.
Yeah, I know. Yeah, I know that. Yeah, it's still a petrochemical product,
Yeah.
and it has other issues with spray foam too. Like in the city of Vancouver, it's actually banned to use spray foam for new construction in single-family residential.
Okay.
So if that's any indication where things are going, it's really, yeah, it's just the toxicity and just the resource depletion that also comes with it.
Okay. It's other issues. Okay, fair enough.
And
Thanks again.
combustibility. It's very it burns very quickly, any foam products, right?
Yes.
So they can really accelerate a fire, so they're not very safe to use in that regard as well.
Yeah. No, I appreciate all those points. So thanks very much, and fantastic presentation. Well, it cuts right through. Thank you.
Thanks, Ferg.
Nice compliment. Absolutely. Our next question up is from Bob in Chicago. Hi, Bob.
Hi, Shannon. Hey, thanks for, hey, Marcel, great presentation, okay?
Thanks, Bob.
Oh, you're welcome. So my question is about mechanically fastened or fully adhered WRBs.
Mm-hmm.
And the reason why I asked the question is because you think about thermal bridging, the thermal bridging happens at the point of contact of the fastener and the bracket, right?
Mm-hmm. Yeah.
And so if you have a fully adhered membrane, I think you'd have less condensation possible forming at that point. Whereas if it's a mechanically fastened WRB, you may have condensation forming behind it and transferring, that into the building. So where would you go with that?
I think it's the opposite. I would say in terms of air tightness, you're right that a fully adhered one would perform better because it seals itself more because of the glue content. The mechanically fastened ones are always more vapor diffusion open. They have a higher perm rating. So if there's any moisture behind that, it would even accelerate the drying out process more than a fully adhered one. There is good fully adhered ones that are vapor diffusion open, but they will never be at a level as a mechanically fastened one because the glue takes away from that permeability. So I wouldn't worry about it in terms of that. It's really around the air tightness. But even saying that, we have done a lot of exterior insulated assemblies with using screws going through that, 2 layers of rock wool or mineral wool through the mechanically fastened membrane. And we never had any issues of not hitting our blow door with test requirements. We're always in, around just 0.2 to 0.3. So if that's any indication, I don't think it's an issue of having to use the fully adhered one. They're much more expensive. That's one thing.
Okay. Let that sink in, everyone. Marcel is averaging on his blow door results. Brag a little, come on.
No, that's not just me. That's a lot of other people do that too. It's in the end, it's we could talk about air tightness. That would be another full hour conversation, but it's about having the plan and having an easy plan of getting air tightness. I think it's not so much about, well, it is about the materials you use. I mean, you have to start with good materials, but then in the end, it's just, the planning for it. And so using an exterior airtight approach with your WRB, in my opinion, is much easier than, if you can do it, than doing an interior with a vapor control layer. Because you have less jogs, less things to deal with, less area of potential leakage.
Would you consider venting the top of your rain screen?
Typically, yeah, it's vented. Yeah, there is only some fire regulation sometimes that you can't vent it into your attic because you could spread your fire, from the wall into an attic. But it's always vented. I mean, part of the rain screen is that it can dry out that moisture, right? First of all, it's a capillary break, so you don't get water getting sucked in what's behind, but also part of it, and the way it was applied in Europe, it was always a vent cavity, really, more than a capillary break. So definitely vented, yeah. Vented at the bottom and vented at the top. Yeah.
Awesome. Thanks a lot.
Welcome.
Thanks, Bob. And next question is from Martin.
Actually, I don't think so. My question was already answered.
Oh, Okay, Martin. Well,
Thank you.
thank you for setting me straight. How about Brian Keach in Pittsburgh? Would you like to unmute, Brian?
Yeah. My question is about the first two of the wall systems you showed, Marcel. And
Okay.
I'm wondering if you can do a panelized deep stud wall without the interior plywood. Instead, just do like a vapor smart air barrier.
Yeah, definitely. Yeah,
Okay.
I'm sure there's people doing that already. Yeah.
Okay.
The
Yeah,
only
I see.
issue from a building science point is not really not always an issue, but having that plywood, which acts as a vapor barrier or vapor retarder, it's not a full-on barrier. And the outside, you're just slowing down that drying out process from that wall, right? So it's a building science issue, and depending on what climate you're in, that could potentially be an issue. Fortunately, we have Mother Nature working with us, which is the plywood is made out of wood. It's wood fiber. Wood fiber expands and contracts depending on what kind of moisture it's exposed to. So if you have a higher relative humidity, and actually the wood fibers swell up a bit, and that plywood becomes much more vapor diffusion open than it would be at a drier level. So that works in our favor. It's nature's smart vapor retarder. But yeah, it's definitely possible and has been done.
Okay, I see. I asked if it's more of a cost issue, and I'm being from the north. You basically want the vapor retarder on the inside if you can get it there. So,
well, from a cost issue, I think having the plywood on the inside is actually going to be cheaper because you don't need to buy your Intello membrane, right? 475 won't be happy, but mine will be happier. Yeah.
okay, I didn't realize that plywood is now less expensive than the.
Well, it used to be.
Plus.
Now I'm actually not sure.
Okay.
Now that Intello is cheaper than plywood.
Yeah. All right.
What I think Marcel is really suggesting in that slide is to find efficiencies in your products. So a product that does two things at once, that's already in place and needs to be there for structural, and now you're using it for air tightness and vapor control. And so it's there on the labor side of just being structural, and now you're just being smart about the materials you're putting in. And I see that wall that Marcel first presented as like the gateway to building passive house, because it's very simple to take a traditional framer, tell them to frame a wall, and they're very good with plywood. They're very good with plywood. You just have to work on the through floors and the rest of the framing of the house that drastically changes. But really good, suggestions on efficiency. Marcel's expertise is that he's the general contractor and the designer, pretty much running design build. So he has very good realities of cost control, right, Marcel?
That's correct. Yeah. So we're always trying to find more efficient ways of building it. Yeah, this is one of them, definitely, like using exactly what you're saying, using a material we already have in our assembly that we need, and then doubling or tripling up on the function.
The thing I like about it, besides what Kevin, I'll echo everything Kevin says. How can you not echo what you said? But the plywood aspect, where you put it, it allows for all forms of regular construction to happen on the interior space. And it's pretty darn hard to put a hammer through plywood, right? So as things happen on the job site, it's going to rebound from those blows. And there's not going to be this hidden little slit somewhere. So I love the durability aspect during construction, as well as the folks that, let's face it, try to put artwork on their walls after we hand over these buildings. I don't know why they do that.
Just a little nail can have so many impacts. Sean, did you want to hop in?
Sorry, I just wanted to say goodnight to everybody. I'm going to go connect with some real friends here. Marcel, always great stuff, my friend.
Real high fives, Sean. Real high fives. Have a great time.
Good night, everybody. Great stuff.
Good night, Sean. Yes, well, anytime we can eliminate redundancy in materials and get redundancy in benefits, we'll take it. Also simplicity in form and then simplicity in details, right? So our next question up is from Sandra. Sandra, would you like to unmute? Oh, looks like Sandra left. let's take a look. Sandra had a couple of questions. The first was, how will the pH ribbon tool change the design process? And I think that one will do because her other one was answered.
Actually, I haven't used it myself, so I can't really answer that question. But I know in principle how it would change. I mean, you're researching your materials, and if you have a carbon intensity requirement, like some codes have that, you need to do a calculation of all your materials, and you need to figure out, am I going to be over that limit, or am I within that limit? And you gotta stick to these thresholds, I guess, and you gotta find the best materials that will work for you that way. pH ribbon is just a tool. Again, in the end, you still gotta just figuring out your areas and your volumes of materials, and then multiplying it and adding it up as a whole. Hopefully, someone else might have some more insight on this.
Yeah, throw some words in the chat if you've used the pH ribbon and you have some experience to share. I think everyone would be interested in that. And our next question in the meantime is from Pierre. Pierre, would you like to unmute?
Hey, Marcel.
Hey, Pierre-André, ça va?
Ça va, merci. Great presentation as always. As you know, I'm a keen proponent of the exterior insulation as well, and use rock wool quite a bit. Have you ever attempted to use it below grade, whether it's foundation walls or under slab insulation?
Yeah, I know there has been promotion for it to go on to be able to use it. I definitely would be open to use it on a foundation wall.
Yeah.
But under a slab, I'm not sure. I mean, we typically do a raft slab or a slab on grade where we relying on low bearing capacity of the insulation. So that wouldn't really work. I don't think it's high enough of a density. But on the footing, on the side wall of the foundation wall, I could definitely see that using. Sometimes we pull it down a bit, a couple of feet onto the ground. I can't see why it wouldn't work. Maybe you put your dimple mat over top of it. I know it has that kind of capacity of self-draining anyway, but I think if it has too much water in the mineral wool, then the insulation value diminishes quite drastically. So I would still try to keep it somewhat dry, not to compromise that. For under the slab, actually, I just want to say that Glavel is in full production, and we're looking at for our next job to get a load out here to the west. And we actually did some calculations in-house, and we figured out it's cheaper to use Glavel than using EPS now under your foundation when you factor everything in. So give it a try. In Europe, it's very common to use foam glass Glavel under your foundation.
Yeah, I've been looking at that. Yeah. Thanks, Marcel.
Thanks, Pierre.
Thank you, Pierre. And our last question. Oh, go ahead, Kevin. Have you used rock wool on slab walls?
I recently had a sample of the 110, the 110 pound PSI density. So they sell it in 110, and then the other one would be 80. So kind of, I would get those two. It's those heavier densities. The 110 is really, really strong. It's still.
Oh yeah, that's got the 110. Yeah.
The 110 is typically the one I use on exterior wall. It's a lot easier to do detailing as well with the high density. My concern, like Marcel, is a water, like drainage and stuff.
Yeah, that's a good point. You need to keep. It's good on density. You just need to keep the moisture away from it, because you don't want hydrostatic pressure pushing moisture in. If you can keep it clean, if you can keep it dry, it's good.
Yeah.
A wet dog's always going to be wet.
Yeah.
And it's hard to dry out when you're underground.
Yeah.
Perfect. Well, our last question is from Rockside Campbell.
Hi, everybody. It's actually Jim Campbell.
Hi, Jim.
But that's okay. I should fix that thing. Great
Rockside's a cool
presentation.
first name, though.
Oh, thank you. It's the area which kind of comes to play. I'm on the Niagara Escarpment out in the boonies in Ontario here. And one thing that, just looking at these different assemblies, and we've done lots of rock wool, and I definitely encourage that 110, we've done it under slab, things like that. but a lot of the future projects we're doing, I really love the idea of taking the VRB as an AB and wrapping a typical building with it. So framing up in 2x4 or 2x6, put a membrane on it. And I wonder about the plywood, just looking at the vapor permeability swings of plywood versus something like the Intello. It seems, my gut reaction is the Intello is kind of more foolproof in terms of just really letting the wall dry out because it has such a swing. But unlike Scott had mentioned, like in Vancouver, you need plywood for sure because of earthquake. We don't have that requirement. So of doing diagonal bracing at say 12 or 24-inch centers so that you can see the Intello from the inside of the building, and thus in the middle of the winter and it's howling storm outside, the insulation guy, everybody's working inside in terms of electricians and insulation. Like you could put the insulation in first using the load bearing wall as the service cavity. I'm just wondering if I haven't seen, like I've seen projects in Europe, things with diagonal bracing, but not that common here. I'm wondering if anybody's done that, or, you know, what the thought is. I just thought seeing the membrane from the inside when you're dense, and the ability to dense back from inside rather than out on scaffold in the middle of the winter would be appealing.
Yeah, definitely. Well, when we're doing the split insulation already, you know, the rapid approach, and it's all about where the location of the plywood is kind of a dew point issue, right? So you got to figure out the coldest winter night on the Niagara Escarpment, probably minus 35 or something Celsius. And then how far is that dew point into the insulation layer? So if your plywood or your vapor control layer, like you know, the Intello is on the inside of that dew point, you're safe. So that would be kind of saying what is safe in terms of your location of your vapor control layer. And doing it from the inside is definitely a possibility. Also, you're talking maybe more like what a double stud wall would look like.
Or the wood eye outrigger, if we could afford wood eyes anymore. They've tripled in price in the last.
Oh yeah, so maybe get one of Mark's T-studs. I don't know what those are in price.
yeah. No, we were just communicating about that. So,
yeah.
But
or you can make a Larson truss, right? You make your own
truss.
Yeah.
You
can use that. Like I've seen a project where they used the old, it was a rebuild of a house, and they used the old framing lumber and used that to make the Larson truss for the new passive house. So they kept the lumber on site. I know there's a lot of labor involved in doing that, but as the material prices get crazy expensive, it starts to make sense again to pay a junior guy to pull some nails and nail together some of these Larson trusses too. Right?
Yeah.
John, one thing to consider is a double stud wall. So one of your exterior walls with diagonal bracing could be your shear wall, and then you could do a double stud interior vapor control layer inside. You may be able to do like a sheathingless double stud wall. That's very common in very extreme climates. Taking away the sheathing takes away a condensation surface. Now you have two fabric or membrane materials. That's just something to keep in mind. I've seen there's a lot of iterations of double stud walls with shear involved in it. You really have to get a really good structural engineer involved. I've seen them where the diagonal bracing goes on the inside face of the exterior wall, where it's running on the inside, and then it gets diagonally done. I've heard people talking about using Simpson strong tie metal, like kind of like straps to incorporate in the wood, but I've never actually seen it executed. But I love the double stud system, but there is troubles dense packing double stud really deep. You just need to have really good precision. But
yeah, the metal straps, actually both Bailey and Simpsons, if you read the fine print, they're not permitted to be an alternative to structural sheathing, which they do use them. You see it all the time in developments and stuff. But
yeah, hurricane straps on roofs and stuff. But
yeah.
finding a really good structural engineer that understands passive house is like or isn't excited by passive house, I think is great. And that's one of the things I've always admired about Marcel is that he's a true designer. He finds engineering solutions to creative problems. If you go back on the videos and you watch his solutions on rigging and moving a few 1,000-pound window, it was an engineering marvel in my opinion. But it's just one of the things of working with smart people, and passive house pushes people to that next level. So.
Oh, great. Thanks.
Well,
Thanks
and
for
it
that.
helps when you have a magic wand, right? For that fairy tale to come true.
Exactly. Yeah.
And I think Bob is the unicorn we need that wants to help. So everyone call Bob.
I work for an engineer. It's not me myself, but that's our main focus here in Manitoba. It's a pretty slow moving rock here in Manitoba, but we're trying to push it any way we can right now. And yeah, we're interested to get into high performance, and I've taken the passive house training, and just now that I'm in the design end of the business here, excited to try and push whichever way we can. But yeah, if anyone needs a hand, we'd be interested to listen. That's for sure.
Throw your company in the chat. Everyone saves the chat, so they'll have your link and be able to reach out to you.
Absolutely. We've got two quick more questions if you have time. Marcel, are you willing to hang out for a couple more?
Sure, yeah, I got another 10 minutes or so, then I go to a parent-teacher meeting.
I hear that. Well,
Not a fairy tale.
Good luck with that. Yeah. Okay, it's Parek again, and then McHugh, and then we'll call it a night.
Hey, Shannon, I'll yield. I've said enough already. So
okay. Well, McHugh, I don't know if it's Fran McHugh. I went to school with a Fran McHugh.
Hi, no, it's an Andrew. I was wondering about a build. So I'm gonna be building a house, and I want to do fully exterior insulation and then wrap it in EPDM. So that would work as the water, air, and just cladding. And I saw, I guess in Europe that they do that once in a while, but nothing here in the US. But just wasn't sure if anyone's done it.
Yeah, rubber, right? The EPDM, with like
Yes.
a roofing membrane. It really depends. Again, when it's completely vapor diffusion closed, you need to realize that. So you need to know where is it sitting in the wall. Is it going to cause some issues or not? If it's on the warm side, where you're safe, then I can't see a problem with it. I don't know how it compares in cost to some of the other membranes that we could use at that location that might be more cost effective.
It would be on the cold side, so it would be the complete outside, like a roof.
Yeah, I wouldn't do that in a heating dominated climate. If you're in Florida, I would say yes, but here, no. No, you're going to run into some issues, especially putting that on top of wood. You're going to have rot behind it, and you're going to have moisture build up. And yeah, stay away from that. You need something that's vapor diffusion open.
Oh, I mean, it would be on top of polyiso insulation, kind of like
And
a
what-
persist build, like the Canadians.
And what's behind the polyiso?
It would be sheathing. So it would be EPDM, then your polyiso, then your sheathing, and then an open stud wall.
Yeah, I guess you already got a vapor closed insulation. Yeah, again, you need to make sure you got enough insulation not to have any condensation issues on your wood. So definitely look at that. But going on top of a foam insulation with something vapor tight is not really an issue because you already are vapor tight behind it. But yeah, the dew point location is critical. I don't know where you're located, what kind of temperatures you're looking at. So, but it's a fairly easy calculation, or you could do yourself or get someone to look at.
Sounds like a perfect example for design pH and the variance in Passive House PHPP.
Mm-hmm.
Model it, and see if it's thick enough and if it works, and can you do it? And then the advanced hydrothermal performance models of WUFI, they can be done too as well. But but one of the things that Marcel mentioned in his thing was find a European example or another example and see if it can fit your climate, and then you don't have to do the modeling. Somebody's already done it for you.
And you see in the comment, Speedy Ian is already providing the example. So when you go to try something new, again, familiarize your team describe the why, figure out the how, and watch out for random nails.
And the why was my first question too. Just you know, what's the major benefit? Is it cost?
Yes, so well, cost and I guess I just wanted I was thinking outside the box, and I see this as being a completely dry, tight build. Poking 1,000 holes in the membrane, sticking on siding didn't seem like a great idea to me.
Yeah, you still gotta support your cladding somehow, right? Or are you leaving it as a rubber house finish on the outside?
Rubber house finish, fully adhered to
well, that's
the
cool.
insulation.
And how's the manufacturer's warranty if it's continued to be exposed to direct sunlight? Is it okay? Like a rubber roof?
I reached out to a representative in Europe for Carlisle. I think it was Heartland, and they said it has good longevity, or their use seemed to work. But when I reached out to Carlisle here in the U.S., it was crickets.
I wondered. Okay.
Yeah, so Carlisle in the US doesn't have that same sort of supportive background for that conversation, right? Because they're heavy commercial, but they're huge actually in that department and level of sustainability. I think all of us would be surprised with how much they are. So if that's your visual aspect, you're the first one in the group that I've heard bring this one forward. So keep on giving us updates and we'll learn together. And right, that's why Shannon, all of us talk about what is the visual thing you're going for, what is the performance thing. So keep us posted and we'll learn together. Thanks for that great thought.
Sure, yeah, I'll let you know. Thank you.
Yeah, and if you've noticed in the chat, Ian's curious for the aesthetic reasons, but he needs a roofer who can make it pretty, and I imagine you would too, unless you are the roofer. So, but well, thank you. Go ahead. I'm sorry.
Yeah, I'm not the roofer. I'm still looking for one. Got a couple quotes, but it's coming together slowly. That's
What part of the country again was that? What climate zone are you?
This is Rhode Island.
Oh, Rhode Island.
Awesome.
Okay. Well,
it was beautiful there yesterday.
There you go. It was beautiful there 3 weeks ago. So shall we have questions, Shannon?
We're out of questions. Unless someone has dropped one in without me knowing. If I missed your question, please feel free to unmute yourself right now and hop in. If you have a last burning question, you can do the same. But if not, I think it's time to just thank Marcel and ask Mark Willie to give him some instructions for a way to take us out.
Real quick, while everyone's here, if you could just take that mute button, throw it away real quick, and give the applause that Marcel deserves for this wonderful presentation.
Thank you, Marcel.
Thanks, everyone. My pleasure.
Thank you. If you wouldn't mind, Marcel, before you go for the parent teacher, can you read the words over my shoulder, pass it to someone, and have yourself a blessed night, my friend?
Yeah, I can read them better. Kevin's background, but I can do that. Passive House Accelerator, construction tech, technical, technique, technology. Good.
Who's next, Marcel? Take a look at who's got their camera on and pick someone to follow up.
Let's see here. Enrique Bueno.
Ricky.
Thank you. Passive House Accelerated Construction, Technical, Technique, and Technology.
Who's next, Enrique?
Thank you.
Enrique, who should go next after you, my friend?
Oh, I would say Norm, New Ecology, my friend. You're coming to Vermont in 2 weeks?
I'm not, unfortunately. My old colleagues will be there, but maybe next year.
Okay.
So passive House Accelerator, construction technology.
All right, kids, that's a wrap. Thank you. Norm gets the award for most T's ever said on the show, I think. And Marcel, thank you very much again. Great show, great information. And we'll have to talk about copyright in this fairy tale because it's a pretty good story.
Thanks so much for having me, guys. Always a pleasure.